Sorry, I got ahead of myself and forgot to do a few examples. So we'll do this quick. There are 4 examples at the end with composite functions and these graphs that go with them. So I'm just going to review that because these are the trickier types of problems. So remember that when you are doing the limit properties for composite functions, you are applying the limit to the inside thing. So in this case, f is on the outside, so that'll be moved to the front. Limit will be moved to the inside with g of x. Okay, that's step 1. Now you're going to find the limit of g of x as x approaches 3. So go to your graph. G of x is on the right. The limit as we get closer to 3 looks like it is 1. That goes in the parentheses. Last step is find f of 1. Remember, f of 1 means what's the y value when x is 1, which is not the same thing as a limit. So you're going to go to the graph of f, you're going to find when x is 1, and you're going to give the y value, which in this case is -2. Okay, let's do one more like that. So, I don't know, let's try C. Okay, let me get some more room here, hold on. There we go. Okay, C, same property, so initial procedure will be the same. Move f to the front, write the limit as x approaches 1 on the inside with g of x. Okay, step 2, find the limit as x approaches 1 of g of x. So g of x as x approaches 1. Okay, now, this is interesting. So if you try to find the limit from the left side, you would get -1. And from the right side, you would get -3, which are not the same. Okay? So what do we call the limit when we get something that's not the same on each side? We get D and E. So in this scenario, it's a little bit weird, but what we're going to do is we're going to check on each side. So we're going to split this problem up into 2 separate questions, I guess. And we're going to say, since this was D and E, right? D and E, which is confusing. We're going to take the limit as x approaches 1 from the left. See what that is. And then we're also going to take the limit as x approaches 1 from the right. Remember, it's still a composite function, so it's not just as simple as taking the limit from both sides. There is an extra step involved. Okay, let's see what happens here. So, when I take the limit from the left, it looks like we're getting closer to -1, okay? So that's going to turn this into f of -1. Okay, go to f of -1. Your graph, the y value of -1, is -6. Okay, you get -6. If we check from the right, oops, wrong way. As we approach, what were we approaching? -1 from the right is equal to -3. Oops. Wait, not -1, 1. Was it still -3? Did I say that right? The limit as x approaches 1 from the right. Yeah, it's -3. Okay, and then we still have to take f of -3. So f of -3 is -6. Okay, look here. The limit initially was D and E, but when we break it down to the left side and the right side, we got -6 at the end from both directions, did we not? So guess what the answer is? The answer is -6. Because you got the same solution from the left side and from the right side. The only reason that happens is because this is a composite function where you're doing more than just taking the limit, you're adding that in as an extra step of evaluating the other function at that point. So you can get an answer even if you have D and E in the initial step. You just have to break it down to finding the limit from the left and from the right, evaluating that in the other function, and seeing if you get the same result. Okay, so you're going to try example B and D. Pause your video now. Those answers should be -7 for B and also -7 for example D. So hopefully when I see you in class on Thursday, we will try to find another example that is like example C so you can get a little bit more practice with that. See you then.